The development of the collaborative gripper started with its modulation and computer-aided design, followed by the manufacturing of the components in a 3D printer. The result is a fully functional gripper with a good overall performance, presenting the many features such as precision and accuracy, velocity, low weight, human interaction, low cost, artificial intelligence, modular and finally, variable close-open amplitude. The gripper can operate in different scenarios. In this test, the gripper is preparing a kit adjusting its properties according to the part that will be grabbed. The working velocity of the gripper doesn't affect the precision and the accuracy. Inspired in the octopus's tentacles, soft robotics fingers were developed, presenting a continuous structure capable to adapt easily to unknown surfaces. These fingers present a good solution to grab organic origin parts like fruit and vegetables. In this performance, the human chose a fruit and the robot will bring it to him and safely. The soft robotic fingers can adapt also to different fruit sizes. Furthermore, the manipulation of flexible materials can be made with the soft robotics fingers. In this demonstration, the robot holds a shirt executing a path predefined. After a few steps, the shirt is totally held and the task is concluded when the robot returned to home position. At this point, the human can remove the hold shirt safely.